Radicals are related to powers. X, y cubed, you can't do anything with it because the bases are different. X, the bases are the same, so it's x to the fourth. So in radicals, what makes it the same? Supreet said it was index. It is indeed index. So this works, but this doesn't. Okay? All right. Now, the next thing you got to be aware of is the multiplication is, there's no trick. It's not to fool you. It's the exact same as regular multiplication. Okay? Here is what I mean. If I gave you, and you can write this down, if I gave you this, 3x times 4y, what would the answer be? 12xy. How did you know that? What did you do? You multiply the numbers and then you multiply the letters. Yeah? Now in this case, because the letters were not like terms, it's just xy. Everyone cool? So you guys are smart kids. What do you think you do here? Gerard. Multiply the coefficients. So it's negative 7 times 5. And then root what? 3 times 8, which is? 3 times 8. We're going to write it out to show you everything. Now, multiply. What's negative 7 times 5?
Negative 35.
Negative 35. And 3 times 8? 24. Do you think we are done?
No.
Why?
Because you gotta simplify.
Because you can simplify 24. Just like in fractions, we would simplify at the end. 24 is, of course, 4 times 6, yes? Is one of those perfect square?
6. 4.
4. So what comes out? 2. So once that 2 comes out here, what happens to the negative 35?
Comes negative 33. Nope.
What do coefficients do? Multiply. So it becomes?
Negative 70.
Negative 70. Root what? 6. Everyone got it? Everyone cool? Okay. Now again, just like yesterday, that's the basis for everything we're going to do now. Okay? But remember, everything else we've talked about in radicals still applies. Okay? And I'll show you what I mean as we go through these notes. All right? This next one looks slightly different. What's different? Doesn't have a coefficient. So in math, if we don't have a coefficient, what's the coefficient? 1. So, can I go ahead and write that there just to remind myself? I can if I want. Do I have to? No. There's no indexes here. Ooh, I said that poorly. There's no indices here.
Ooh.
That's the plural of index, indices. Well, that's okay. You're entitled to that opinion, but it is the word. Just like the plural of codex is codices. Anyway, there are no index numbers there. Then I don't have to say the wrong thing and you don't have to hear indices. Because it does sound a little like something that might get between your toes and make them itchy or something. What do you got? Oh, I got the indices. Whew! It's killing me. Anyway, remember, with index numbers, the thing that isn't written is what?
2.
A 2. It's the only time. So, 1 times 3 is 3. Root 2 times 8, 16. Would we stop there? Have to simplify 16. What's the root of 16? 4. So this is 3 times 4, right? Which is 12. All right? Everyone cool? Everyone is cool? Okay. So now I'm going to take the time in this box right here to show you something that I think is common sense. But for some strange reason, kids don't seem to remember that this is true. What is the square root of 2? Damn! What is the square root of 4? 2. Everybody cool? That's easy peasy, right? Okay. I'm going to multiply the square root of 4 times the square root of 4. is the square root of 4? 2. So I'm multiplying 2 by 2, aren't I? What is the answer? 4. So what answer goes up here? 4. Everybody cool? Okay. So now I've got the square root of x times the square root of x. What must the answer be? X. Everyone got it? It doesn't matter what the square root is, even if it's irrational. If you square it, you get that number back. That makes sense, doesn't it? Right? So if I had the square root of some crazy irrational number, 321.7, and I squared it, what's my answer? 321.7. Everyone cool? I take the time to show that there because as you can see in D, you're about to do that. And that, for some strange reason, a lot of kids are like, I don't know what to do with D in the past. So, what do you think you would do with C? Does it look any different? It's the exact same thing, isn't it? Okay. So let's do so. Negative 8, I didn't want to be working in red. Negative 8 times 6, and the root of 6 times 12. Negative 48, root 72. I know 72 is 9 times, I know 72 is 36 times 2. Take out the square root, right? So I've got 6 times negative 48 root 2, which is negative 288 root 2. Is everyone okay with that? Yeah? Okay. Now I want to show you something. Look in here. This is the very beginning of something you can do to make your life easier later. If you only listen to me in number 1 and say, okay, multiply, multiply, done, got it, let's go. If you stop listening there, then later on in math class, you're going to be in trouble. Okay? Watch this. I'm going to do this again in blue, except I'm going to do something slightly different. Negative 8 root 6. And here, that's 4 times 3. So that is 12 root 3. Agreed? I simplified in the question. Is everyone okay with me still? Then I do my math. Negative 96 root 18. Then I'm only simplifying 18, which is 9 times 2. Take out the 3, and I get negative 288 root 2. Now it doesn't look any easier here, does it? It's about the same amount of work, isn't it? But what if this first 6 was 72, and this second radicand was 96? Would you want to be factoring 72 times 96? No. So you can simplify at the very beginning. Picking up what I'm putting down? All right, so let's look at this next one real quick. What's root 3 times root 3? 3. And what's 3 times 1? 3. So what's 3 times 3?
9.
9. Everyone got it? Now, should we write it out normally to make sure you get it? Yeah, of course we will. That's 3 times 1 root 3 times 3. Right? Out comes the pair, and outside here now I have 3 times 3 times 1, and I left nothing under the bracket. 3 times 3 is 9. Everybody cool? All right. Now, remember, Everything I've ever taught you in this class and everything you've ever learned in math comes to bear in grade 10. So looking at this question, it looks weird, but you all know how to do it, don't you? Because what if I had, and don't write this down, 3x squared plus 2x minus 7? What would you do? Yeah, does anyone remember the proper word for it? Starts with a D.
Displacement.
Distribute. Displacement is what happens when you get in the tub and the water goes up. That's okay, buddy. Everybody remembers how to do this, right? You distribute, wouldn't you? So what do you think you do here? The exact same thing. So you got to do it 3 times. What's 5 times 3? 15 root 8 times 2? 15 root 16. Plus 5 times 2? 10 root 8 times 3? 24. Minus 5 root 8 times 5, 40. And then we'd simplify, yeah? What's the square root of 16? Times 15? 60. 24 is what? (24) is 4 times 6, yeah? What's the square root of 4? 2. So out comes a 2. What's already out there? 10. So it becomes 20 root what? 6. Lovely. And 40 is, what's a perfect square that comes out of 40? 4. 4 times 10. What's the square root of 4? Minus 10 root 10. We left a 10 in there. Is everyone cool? Okay, you see how it's all coming together now? All that crap that you learned, like, what bothers me about math in Canada is you guys got to here in grade 9, you did some square rooting in grade 9, we could have gone one more step in grade 9 and then gone even further in grade 10. But we stop in grade 9, just when you're starting to get it. I don't know why. F, what's different?
Cubes.
Are they both cubes?
Yes.
So can we multiply?
Yes.
Excellent. Do you think anything else changes?
No.
No. Now, again, if you haven't been paying attention to me, you stop listening after A, what are you going to do here? You're going to go 16 times 54 and get 864. How many of you would like to factor 864? That's not a factor tree, that's a redwood. Right? So what can we do instead? Simplify. When in math class should you be looking to simplify? Always. Every single chance you get, you should be simplifying. It shouldn't even be an instruction on a test or in a textbook, should it? Right? It's always what you're doing. So if we are going to simplify these, the only thing we got to remember is we got to look for cubes now, don't we? Is there a perfect cube that goes into 8? Is there a perfect cube that goes into 16? Shut up. I told him the answer, so he got it. Nice job. 8 times 2. What is the cube root of 8? 2. So I've got 2 cube root 2, don't I? Is there a perfect cube that goes into 54? I got it that time. You're kind of right in thinking of 3. It's 27, right? That's 27 times 2. Does 27 have a cube root? What is it? 3. So we get 3 cube root 2, right? Now it's super easy, isn't it? Now go back to A. What do I do with the 2 and the 3? multiply them to get 6. Now, again, if you haven't been paying attention, you're going to make a mistake here. Right? Because if you've kind of been paying attention, you're going to see root 2 times root 2, and what are you going to tell me the answer is? 2. But it's not root 2 times root 2, is it? It's cube root 2 times cube root 2. So what is it? Cube root 4. Because 4 doesn't have a cube root. Everybody cool with that? Everybody good? Okay. So what do you think you're going to do with G?
Simplify.
Simplify, 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 right? Because who wants to factor 28 times 63? It's going to be like 2,000. That's a big tree. So what do? Simplify now. Go. Is there a perfect square in 28? What? 7 times 4. Is there a perfect square in 63? 9 times 7, yeah? So now it's real easy. That is 10 root 7 times 9 root 7, right? Now, 9 times 10 is 90, and root 7 times root 7 is what? 7. So 90 times 7. What's 9 times 7? 63, and then we add a 0. Is everybody cool with the basics of multiplying? Everyone is Gouda? Gerard? Okay. Anybody else? Going once. Going twice. Going thrice. Okay. Notice I have no assignment from your textbook for multiplying radicals. Right? But I do have, when you turn the page over, what?
11 questions.
A radical assignment. Okay, now remember, I haven't, as always, I have not taught you every single thing. You have not seen an example of every single thing on that page. But you have the math knowledge buried in your head to solve everything on that page. Because remember, math rules work when it looks different, right? You all knew how to do this, and you were able to apply it to this. You picking up what I'm putting down? Okay. Now, it is 8:50, which means I'm going to stop recording.